Recently, I introduced the term penalty terms for use in your sales comparison approach and in how you apply adjustments. And I had some pushback on that, people not really understanding, thinking this is something I'm making up or something new. And I wanted to say this is actually just a mathematical representation of something that has been in traditional economics and appraisal theory for a long time. So the theory of functional obsolescence that has been in appraisal textbooks now for nearly 100 years. And before that, the concept was still there. It was always referred to in terms of, you know, the utility of a property and how it maybe it depreciated from inutility or superfluous improvements. Those type of terms might have been used. But all of that is in the context of the broader law of diminishing marginal returns. So this is an economics law because it is it's really uniform in terms of its application and observing this throughout different types of products and different types of markets. There's just really no consistent exceptions to that. That's why it's called a law of diminishing marginal utility. And that law is what really goes into demand theory in terms of what demand curves look like. A demand curve is a curve because of diminishing marginal utility. So there's a concept called elasticity of demand. These are all economic concepts that are well over 100 years old and have been used across industries and applications because it's if you're analyzing markets and the way that markets work, which we as appraisers do, then we're going to be dealing with the law of diminishing marginal utility. So in thinking about that and in thinking about how we as appraisers deal with functional differences, functional utility differences in properties, a way to quantify that mathematically is through a penalty term. So what you're seeing on the screen right now is I have a little test grid I made to demonstrate what this looks like and what it looks like mathematically and how you can test it. So this test grid I've got right here, I've got a penalty term that's set up for bathroom adjustments. So I am defining my market segment norm for what would be the normative number of bathrooms in this market segment at 2. And so I've got sales in a grid that differ in terms of numbers of bathrooms. And how can we test if a penalty term is appropriate or not? Well, the very first thing is it qualitatively appropriate? When you're analyzing the market, does the behavior of the market match the law of diminishing marginal utility within this segment? So in this case, it would be a situation, well, if I'm saying the market norm is for 2 bathrooms and I have a sale with 1 bathroom, like sale 1 here, how is the market going to behave? And is the market going to behave the same way as if I have maybe an additional bathroom? So here we're looking at assessing qualitatively, do I have a functional deficiency or do I have a functional superadequacy? And those don't have to be black and white extremes. They can be graduated scales. So yeah, I'm starting to see that, well, people don't quite demand that 3rd bathroom as much as they demand the 2nd bathroom, which is the market norm. So the penalty term is a way to take what would be a linear adjustment otherwise. So if I wanted to apply a linear adjustment, what I'm saying is I'm defining that penalty term at 0%. There is no penalty, aka a linear adjustment. If you were to look at this mathematically, this would be the reason it's called a penalty term. It's a actual term in the equation. So a linear equation will have a single term for multiplying the coefficient, which is your adjustment, multiplied by the number of units that you're adjusting that are different. So in this case, if I'm adjusting for this first comp and there's one bathroom versus two, $12,000 adjustment, that's what I'm defining as the overall adjustment that's been derived. Same thing, if I'm going from 2 to 3, I'm making a negative $12,000 adjustment. And if I've got a half bath in here, same thing, same concept. You all know this, you do this every day. So if I want to say, I'm noticing qualitatively that I think there's going to be some functional utility differences among this spectrum of my sales in how the market's going to react. So if I believe that to be true, then assessing a penalty term of 0 isn't really matching the market. I'm not matching my math to the market. I am setting a penalty term of 0 implicitly. I didn't realize that's what I was doing, but that's what I'm doing if I'm saying a linear adjustment. And that's fine. That will have a certain impact. But I've set this up so that we can test. So we can test a penalty term of 25%. So you can see when I use 25%, the adjustments change. So I've got a $15,000 adjustment now for this bathroom difference from 1 to 2, and $9,000 for the 2 to 3. So that's recognizing that diminishing marginal utility. Well, how do I test that penalty term coefficient? Well, that's where standard deviation and the coefficient of variation come in very handy. You can see down here at the bottom, this tells me the dispersion of my grid. And so if I have a penalty term of 0, I have a standard deviation of 4518. Say I put in 25%. Now my standard deviation is 3902. That's less. So my coefficient of variation also declined. And that means that my spread just got narrower. So me modeling for a 25% penalty term was proven in this market to be better than 0. It fits the data better. Now, some of you may be thinking, well, are you overfitting the data? That doesn't apply when we're matching our qualitative observations with the math. If we do it the other way around, that's where overfitting is a problem. I'm trying to make the math work first and then trying to apply that to the observations of the market, and that doesn't usually work very well. That's where overfitting comes in. The nice thing about the way that appraisers do the sales comparison analysis, it solves for overfitting as long as appraisers are not including or excluding adjustments based on the numbers. If you're assessing the differences and then trying to model those quantitatively, then overfitting is not going to be a problem. So, well, okay, what about something higher? What if I do 50%? Okay, my coefficient of variation went down, my standard deviation went down to now 3764. So I just proved that 50% is a better penalty term than 25%. What if I go to 75%? Okay, now my standard deviation started to go back up. My coefficient of variation is now a little higher. So what I just proved was that a 50% penalty term is better than a 75% penalty term. So I could solve for the specific exact percentage of penalty term here that would best model this grid. But it's going to be somewhere close to 50%, but between 25 and 75. That's been proven to best fit the data as it has been presented and the qualitative differences that I've noticed. So this would be a way that you could incorporate a penalty term and use that and prove that in your analysis. It doesn't have to be super complicated, really. This is something you've already been doing to some level. There's a functional utility line in most of the residential appraisals that you put out, and so anytime you're using that adjustment line, you're most of the time, however you're doing that, you're actually creating a non-linear adjustment. And so just to show you, here's what it looks like if I were to graph out these different, well, these aren't the same specific adjustments here, but this is graphing a linear adjustment versus a penalty term adjustment. And you can see the red line is the penalty term adjustment. Let me get myself off the screen. So which of these lines looks more like a demand curve? Well, that would be the red line, because it is matching the law of diminishing marginal utility. It is recognizing that there's elasticity in demand, which is sort of the economics lingo for recognizing differences in functional utility. So I hope that that this helps, that this has provided a little bit more context, a little bit more light as to what I'm talking about and what it looks like to incorporate that in your appraisal practice.